function by the algebraic form. Okay, so now we will read the Boolean algebra in another form. So our today's topic's name is simplification of Boolean functions. So everyone write in your script that simplification of Boolean functions. Today's topic's name is simplification of Boolean functions. Observe. So you have to be attentive because this topic is little bit complex. A implementation of a Boolean function requires the use of logic gates. The smaller number of gates with each gate other than inverter having less number of inputs may reduce the cost of implementation. That means how much the logic gates you will use, that much the cost will be increased. So there are two methods for simplification of Boolean functions. So previously these two topics said that why we will the needs of Boolean simplification of Boolean function. That means why we will simplify the Boolean function, because if it is more complex, so number of input will be more and the cost will be also more. That's why we will simplify the Boolean function and for make the effective. Then the algebraic method, there are two methods for simplification of Boolean function. Already we have covered one method, that was the algebraic method. So how many methods for simplification of Boolean functions? There are two methods. One is algebraic method by using identities. In previous slides, previous chapters, previous topics, we read different types of identities for simplified the Boolean functions. Is not it? Can you remember? We read 10 types of identities. Is not it?
Yes, ma'am.
Everyone, can you remember? So for that reason, that topic's name was Boolean algebra. That means we use the algebraic method. Now in this lecture we will learn the graphical method. So how many types of methods are there for simplifying the Boolean functions? Everyone?
Two types.
Two types. So did you understand?
Yes,
everyone, what I am saying? That for simplifying the Boolean functions, we will follow two types of method. One is algebraic method using identities, which already we covered. Okay. Another is graphical method by using Karnaugh map. So now in this lecture we will cover the graphical method using Karnaugh map. The Karnaugh map shortly denoted by K-map. Okay. So if I say that K-map, that means you have to understand this is the Karnaugh map. K-map method is easy and straightforward. This is easy and straightforward. A K-map for a function of n variables, so if there have n variables in a function, consists of 2 to the power n cells. So a K-map for a function of n variables consists of 2 to the power n cells, and in every row and column, two adjacent cells should differ in the value of only one of the logic variables. Okay. So these are the attributes of K-map. If I ask you that, tell some attributes of K-map, so these will be the attributes. The first attribute is K-map consists of 2 to the power n cells, where n is the number of variables. That means if we use 2 variables, the number of cells will be 4. If we use 4 variables, the number of cells will be 8. Okay, so clear everyone the first characteristic. The second characteristic is that every row and column, so obviously for a cell there will be row and column, two adjacent cells will differ the value of only one That means one value, for one value, two adjacent cell will be there, the logic variables. Okay. So this is the two attributes. So now see the example, so that will be very clear for you. So see the example. Cell numbers are written in the cells. So two variable kind of map in two variables. This is A and this is B. Okay. So this is row. A is denoting by row and B is denoting by column. So how many? What is the value of n here? Everyone, how many variables are there?
Two.
There are two variables. Is not it?
Yes,
so there are two variables. If there are two variables, so how many cells should be there?
4.
4. Why?
Because 2 to the power n.
N. Because our first characteristics was that if we use n variable, our number of cells will be 2 to the power n. So if we use 2 to the power n, that means 4. Okay. Now observe, always you have to consider row first. That will be row multiplication column. Row and column. Okay. So 0, 0. So observe. So first will be from row, the second will be column. 0, row value is 0, then column value is, for first one, row value is 0, column value is 0. So what will be the value? Cell value for 0, 0, cell value will be 0. Okay. Now row and column. So row value is 0, column value is 1. 0, column value is 1. Observe this one. Okay. 0, 1. So what will be the value? 0, 1 is equal to 1. Okay. Now second row value is 1. Row value is 1 and column value is 0. So what will be the value now? 0, 1. 0, 1 is equal to, if we convert it into decimal, 0, 1, what will be the value? 2. So observe, 0, 1 is equal to 2 is written. This is written. Did you understand how the map is constructed?
Yes, ma'am.
Yes, ma'am.
Okay. So now say the row value is 1, column value is 1. Okay. 1, column value is 1. So now what will be the cell value?
3.
For 1, 1 location, cell value will be 3. Because 1, 1. That means in decimal this is 3. So this is the way how we will solve the Karnaugh map. At first we have to consider row, then we have to consider the column. Then we have to combine row, column. Then we have to find out the corresponding decimal value. So are you clear everyone how the Karnaugh map is constructed?
Yes, ma'am.
Everyone?
Yes, ma'am.
You have to understand, otherwise when we will read deep topics, more detailed topics, then you could not be able to understand. Okay, so my request to everyone, please everyone try to solve your understanding level from previous topics. From the first day. Okay, so are you clear everyone the how to Karnaugh map is constructed? So now if I give you 4 variables, 3 variables, 8 variables, so easily you can solve it, is not it? So at first we will combine row and column, then we will find out the decimal value, then we will put that in the corresponding cells, row and column. Okay?
Yes,
Clear? So
ma'am.
everyone please take a note of this
Yes, ma'am.
slide and how I describe, write that note by your own language. Everyone please take a note of this slide. So I hope everyone has been taken this note.
Yes, ma'am.
Sharmin, are you here? Sharmin Akhtar?
Yes, ma'am.
Do you understand?
Yes, ma'am.
Okay. Now observe, this is 3 variable Karnaugh map. So what will be the combination? A, B, C. At first A, then B, then C. Okay? Because I have said that we will follow row, then column. For the combination, we will follow row, then column. So what will be the combination? A, B and C. Okay? So now you will find out for A, first combination will be 0, 0, 0. Then for this one 0, 0, 1. For this one 0, 1, 1. For this one 0, 1, 0. Then second row 1, 0, 0. Then second row, second column 1, 0, 1. Then this one 111. Then this one 110. Okay. So now 4 variable Karnaugh map. So everyone observe 4 variable Karnaugh map. What is 4 variable Karnaugh map? So what will be the combination? First one, who can say? Who can say what will
4
be the
zeros.
function
Ma'am,
here?
0, 0, 0, 0, 0.
And function will be
Zero.
A B C D. A B C D. Okay? Because at first we have to consider the row. The row is A B, then C D. So 0, 0, 0, 0, A B C D. Like this way, there have how many map will be there? How many shell will be there for 4 variables?
16.
16, because we will follow 2 to the power n. Very good, Ashikujaman. 2 to the power n equal to 2 to the power 4 equal to 16. That's why there have how many cells are there? 16 cells. Now we will learn the literal, min term and of n variable. We will learn another 2 topics, min term and max term. And literal. What is literal? The definition is written here. A variable or its complement is called a literal. So we can say here, this is 4 variable K-map. We can say here 4 literal K-map. Okay? So K-map means variable means literal. The literal is the variable or the complement. Okay? So mean term, what is mean term of n variable? A product of n literals. So what is mean term? Mean term means a product of n literals is called mean term. So there have some characteristics of mean term in which each variable appears exactly once. In which each variable appears exactly once in either its true or its complement form, but not in both. Okay? So when we will say example, you will be much more clear. Just now remember that what is mean form? Mean form is the product of n literals. Now we will see the characteristics. The first characteristic is in which each variable appears exactly once in either its true or its complement form, but not in both. The second one, which is equal to 1 for exactly one combination and of values of the n variables. Okay, so you have to remember all these things. Then mean term and max term. For every K map, each cell has a mean term associated with it Thus, for cell number 13 in the 4 variable K map, the min term is A, B, C dash D. Okay, so in min term is denoted by this one. How is min term is denoted? Min term is denoted by small m. Then base will be 13. Okay, why we have taken the min term 13? Let's see. So A, B, C dash D. Observe. So we are saying that we are finding the min term of 13. Okay. So what is the combination of this 13? Can anyone say? 1 1 0 1. That means, so one value is for A, then another one value is for B, then C. 0 means C. Okay, C, but this is in 0. That means the opposite of 1. So this will be C bar D. Observe the combination. C bar is once, only once is there the C bar. C bar টা কিন্তু শুধু এখানে একবার এসেছে, if you observe. Okay, so that was in the characteristics. So did you understand? This is the min term. This is equal to m, base will be 13, m13. So that's how we will find out the min term. So did you understand, everyone? সবাইকে বুঝতে পেরেছেন?
Could you say that again?
Yes,
Why
ma'am.
we are using C bar?
Ebar, why? So observe this 1101. Did you observe this one?
Yes, ma'am.
So from where this one came? We are considering M13. Okay. So what is the combination of M13? What is the function? Function is 1101.
01.
Is not it?
Yes, ma'am.
That is A, B, C, D we are considering. So A is 1. So when this is 1, we are saying this is A. When this is 1, we are not saying the invert value.
Oh, now
Okay.
got it, ma'am. Yes, ma'am. Now got it.
Okay. So now you got it?
Yes, ma'am.
So because the value of C is 0. So if we say 1 is equal to A, B equal to 1, A equal to 1, if C equal to 0, so that will be inverse. That why we have said A, B, C inverse D. Because 1, 1, 0, 1. This 0 is belongs to C. That's why this is inverse. And this is the min term of 13, A, B, C inverse D. So clear, everyone?
Yes, ma'am.
Thanks, Ashikujaman, for asking the question. You asked the question and I hope you understand. Those who are not asking the question, I don't know either you understand or not.
Yes, ma'am, we understand.
Very good, if you understand. But I hope you will ask questions. Now, so did you understand min term? Now we will read the max term of n variables. So min term is the product of the literals, n literals. Max term is the sum of n literals. So this is the main difference between min term and max term. Min term is the product of n literals and max term is the sum of n literals. Okay? So in which each variable appears exactly 1 in either its true or its complement form, but not in both. That means there cannot be both. If there have inverse, so that will be one's inverse. Otherwise, while inverse, one will be not inverse form. This can, okay, which has a value of 0 for exactly one combination of values of the n variables. Here we are considering the value of 0. Previously for min term we are considering the value of 1. Now for every K map, each cell has one potita cell. Each cell has one max term associated with it. Thus, for cell number 13 in the 4 variable K map, so max term is denoted by capital M and min term is denoted by small m. So capital M 13 is equal to A inverse plus B inverse plus C plus D inverse. Observe. So opposite. So previously that was A, B, C inverse D. Now we are writing plus sign also. Previously that was multiplication sign dot. Now we are writing plus sign. A inverse plus B inverse plus C plus D inverse. So by the De Morgan's law or by the De Morgan's theory, min term is equal to inverse of max term. So, by the De Morgan's law, we can say, or De Morgan's proof that min term of any value will be equal to the inverse of the max term. Okay? Adjacent min terms. Okay, so I will not teach you more today because these topics are critical. That's why I want that all of you be clear up to this one before the adjacent. Everyone?
Yes, ma'am.
So I hope all of you will read it at your home. All of you.
Okay, ma'am.
Okay, and you will clear your concept before we go to the next topics. Okay?
Okay, ma'am.
So now everyone be ready for the attendance. I will provide this slide. Don't worry. Everyone please turn on your video. For the attendance you have to turn on your video.